All right, let's take a look at a problem and use these derivatives of the trig functions. We've got all 6 derivatives of the trig functions here: derivative of sine, cosine, tangent, cotangent, secant, and cosecant here to use. So I've got a function which is secant of x times the tangent of x. That's f of x. So I'm going to take the derivative, f prime of x. I'm going to use the product rule, 1d2 plus 2d1. So 1d2 plus 2d1. So I've got the secant of x times the derivative of the tangent x plus the tangent of x times the derivative of the secant of x. Okay? So that means we've got secant x, the derivative of the tangent. Okay, we've got that over here. That's secant squared plus the tangent of x. Now we need the derivative of the secant. The derivative of the secant is secant x tangent x. Okay, so once we see the operators are gone, we've taken the derivative of the function, okay, which tells us then we've got secant x times secant squared plus tangent x times secant x times tangent x. Okay, so it looks like we've got some secant tangent identity somewhere within. And at this point, I may not remember one of the fundamental Pythagorean identities. So I know the sine squared plus cosine squared equals 1. And secant has cosine in the denominator. So if I divide through by cosine, then I get tangent squared x plus 1 equals secant squared x. Okay, so what that means is I'm kind of looking for that a little bit here. I can see I've got a tangent times a tangent here. Okay, it also looks like I've got some type of secant squared, but maybe I can factor out a secant here and see what I'm left with. So I take out a secant of x. I'm left with a secant squared plus tangent squared x. Okay, so that means then I've got a secant here, I've got a secant here, and I've got a tangent. So the tangent is the one that doesn't belong, if you want to think of it that way, so to speak. But it looks like I can swap out for tangent squared. So I already know tangent squared plus 1 equals secant squared. So if I move that 1 to the other side, I end up with secant squared x minus 1. And that's what tangent squared of x equals. So I'm going to take this another step. I got secant, not squared, just secant of x. And then I've got secant squared x plus tangent of x, which equals secant squared x minus 1. Okay, that tells us we got the secant of x times 2 secant squared x minus 1. I could redistribute the secant x in here. So I've eliminated the tangent. I do have one trig function here. But again, with the trig, sometimes the identities and the answers that you're looking for are done or you're found after you've done the calculus. Because once we've gotten rid of the operators here, we're down to all trig functions. So it's kind of like a verifying problem depending on where you want to take your answer to. But again, just like with any other derivative, once the operator's done, I could use this line here if I needed to find the slope of the tangent line at any x value. I did reduce it, so to speak, or reorder it, and again, just by putting it in terms of tangent, but you maybe end up verifying to the answer that you're looking for here. Okay.